Hello and welcome back to our pre-calculus enrichment series. And in this episode, we're going to be talking about conics applications. There are a lot of different rules that have to do with these different conic sections. And rather than going through all of those, I think it would be better to just show you some applications. You can see on the left kind of what conics really are. Basically, they're just cross sections of a cone. So this is a really good image. It's kind of showing you what these different cross sections look like and the different curves that you can get out of them. And so we're going to be looking at three different ones. We have the parabola, which you're probably familiar with already, the ellipse, and the hyperbola. So let's get started. First, let's talk about what defines a parabola. There are a lot of different criteria. But I want to talk about some things that you are probably less familiar with, which would be the focus and the directrix of a parabola. So let me show you a little bit of what this looks like. If I have an upward facing one, we would have kind of the focus inside the curve. And then this horizontal line, which is the directrix, it's not really a part of the curve, it's just a line that we draw because there's special properties with it. And so we draw that under the curve. And so that's what they look like. I can also draw a downward facing one. And so this will be a little different. We're still going to put the focus inside the curve, but now our directrix is above the curve. Really, if you ever get that mixed up, the only thing you need to know is that the directrix cannot intersect the curve. So obviously if it's facing down, I mean, you couldn't do this, like that would be bad. So yeah, that's kind of what that looks like. And there's some special properties with this. The rule is that a given point on the curve, on the parabola, is equidistant from the focus and directrix. If that is confusing, I'm going to show you an animation here. I can talk about what equidistant means. Okay, so here's an example of a curve. This is not my animation, but it's a pretty good one. So we have the focus right here. It's on the axis of symmetry, which is just kind of that imaginary line that divides the curve. That probably sounds familiar from like Math 2 or something. Point C, this is my point along the curve. And then that red line right there, that's my directrix. So notice how wherever I put point C, these distances are always the same. The distance from the focus is the same as the distance from the directrix. So you can see by looking at these numbers here, 12.57. I can also put it at the vertex. So we got a distance of 5 and another distance of 5 below point C. And when we're talking about math classes, this can be pretty useful because you might be given the equation of a curve, and if you know the equation, you probably know the vertex. And then let's say you know where the focus is, so you know the equation, which from that you can find the vertex. So that's where point C is. And if you know where the focus is located, you can sort of find that distance and then take it the other direction in order to get to the directrix. So this is a really good property if you're missing information in a math problem. And you can kind of use the equidistance rule to find the missing piece. So that's my animation for you. Let me go back to the notebook. And let's talk about actual applications. So there are definitely a lot of different ones. I want to talk about parabolic reflectors, which sounds super fancy. It's kind of just a bowl. It's really what it is, except it's not circular. I think bowls are usually circular, but this is more like in a parabolic shape. And we use parabolic reflectors. We use them for spotlights. We use them for headlights in your car. and also TV dishes. If you have cable, I took a picture of my TV dish. It's kind of hard to see, but that's what they look like. And so let's talk about how these work. Basically, if you have parallel rays of light, in this case, it would be radio waves, which travel a very long distance to get to this TV dish. These parallel rays of light, they're going to approach your TV dish. They're going to hit the inside of the dish, and then they're going to bounce off and hit the focus. I personally don't know how to model this two-dimensionally. I'm pretty sure you can if you just wrote like a standard parabola, but I'm showing you what this looks like three-dimensionally. So we have all these parallel rays of light. They're going to hit the dish and bounce off into a focus. That focus is where we put the antenna. So the actual shape itself, that is not your antenna. The antenna is just one point located in the dish. And that's because we're basically concentrating these rays of light into one point. They're all bouncing off and hitting this one little space. And so it takes a weak signal, it makes it a lot stronger, and that's how you're able to have cable. So that's pretty much it. And in the next video, we're going to talk about the ellipse. Following video will be about the hyperbola. So thank you for watching.